Okay, we're starting our EOC review. My recommendation is that you have a notebook that you are going to use, not just a plain sheet of paper. There are 8 days of review, and I have 8 important questions to ask. So let's get started. Alright, so this is Algebra EOC review, day 1. And today is the 15th. Alright, so we're going to start with an essential question. We'll do a review, and then we'll play a game to make sure we have it. If I move too fast, y'all let me know. If I write it, you write it. Okay, the essential question is, I gotta find it. Alright, how do I explain the impact of adjusting a quadratic function? How do we describe the impact of adjusting a quadratic function? Now, what I want you to understand is that everything that I'm going over is in an effort to make sure that everyone has the opportunity to test at a distinguished level, because these are the ALDs. ALDs are achievement level descriptors. So this is the Georgia Milestones achievement level descriptors for algebra. What I've done and what we're going to do over the next 8 days is, if you look, there are 4 levels to milestones, and they are beginner, developing, proficient, and distinguished. I am forcing us to all operate in an area of distinguished learners. So the questions and the notes that we take, they are not focused on the lower level beginning learner indicators. So, like, I already expect that you know how to identify a term in an arithmetic sequence. I already expect that you know how to identify a graph of a linear function. So we are operating over here on this last column of distinguished learners. And as a distinguished learner, when it comes to quadratic functions, because that is like one of the major domains, when it comes to quadratic functions, y'all see right here, the sum and product of rational and irrational numbers. Rad times rad is rad, rad plus rad. That's distinguished learner level concepts that we're focusing on. So keep that in mind. Converting between forms of equations. And this is the one that we're focusing on today. Given a quadratic function, we can adjust the starting values by multiplying the inputs and outputs. This is nothing but shifting the graphs, and that's what we're focusing on today. So everything that we do for the next 8 days, I'm trying to push everybody to this level 4 of distinguished. Y'all understand that? All right. So here we go. How do we describe the impact of adjusting a quadratic function? The quadratic function and the impacts, there are 3 of them. Go ahead if you need to sharpen your pencil. Yeah, I'm going to go back in just a second. I got to find the rest of the question. The first one is f of x plus k The second one is k times f of x. There are four of them. F of k times x. And then the last one is f of x plus k. So we need to make sure that we can describe all of these impacts. Give you a moment to catch up. Okay, we are gonna approach this question with the schema from two former things. Draw a line across here, and then go ahead and split this first bar, because I do want to split the paper 2/3, 1/3, 2/3. Over here, before we even talk about them, I want to give you some reflections from the past, okay? One of the reflections that I want to give you is, when y'all were in middle school, there was a geometry lesson in 8th grade, and it was like translations, rotations, and it's like two more. Translate, rotate, reflect. Y'all remember those moves in geometry? Y'all don't remember the geometry moves? Okay, so let's think about geometry real quick. Reflect, translate, rotate. And then the second thing that we're going to reflect from the past is vertex form of a quadratic. We're going to put these two things together to help us understand the adjusting of these quadratic functions. Alright, so first, vertex, reflections from the past. Number one, geometry. Reflect, translate, rotate. Number two, vertex form. I want to bring back these two things to tie in to the shifting. Okay. Vertex form, where are you? Right here? Reflections from the past. The first thing is geometry from 8th grade. We're going to talk about reflecting, translating, and rotating. This one is vertex form. I'm going to do vertex form first. Vertex form for a quadratic. A quadratic in vertex form is y equals, and if you see f of x equals, that's just another way to write y. So y equals, f of x equals x minus h squared plus k. This h and k represents the vertex. But this value is the opposite of what's in the formula. Do y'all remember that at all? Okay, so if you have f of x equals x minus 2 squared plus 3, then as a reminder, you should know that the vertex, the minus sign, is already in the formula. So the vertex is not at negative 2. The vertex is at positive 2, 3. H and K represents the vertex. So if we draw this graph, the vertex is going to move not in the negative direction like you would think, but in the positive direction and up 3. This is where the vertex would be for this quadratic. So if this vertex is at 2, 3, then that tells you that the parent function went from being right here to going 2 to the left and up 3. Make sense? Yes or no? 2, 3. The vertex tells you how the graph shifts. So I want you, I'm going to give you a minute, let that soak in. When we took this vertex and we moved 2 units to the left and 3 units up, did we reflect, translate, or rotate? Do you remember what those words mean? Nope. Alright, when you reflect, you flip the graph. So it may go from being here to being there. Rotate. Reflect is a flip. It may flip vertically across the X, or it may flip horizontally across the Y. Here's the other flip. This is across the, which axis goes this way? X axis. This is a flip across the Y axis. Alright, so when you look down here, we did not flip this parabola. We did not reflect this parabola. What causes a parabola to flip either vertically or horizontally? Would it be this one, this one, this one, or this one? Do we know yet? Alright, here we go again. Big brain, turn it on. Look, a reflection is a flip across either the X or the Y. Your phone's supposed to be off. Y'all ain't got no music on, so ain't no need to touch your phone because it's off. I hate that's going to be on my public video too. But yes, America, we have students who, cell phones are an issue in, Put your phones away. Alright, when we reflect, when we move 2 up, 2 to the left and 3 up, that is not a reflection because a reflection is a flip. So, this minus and this plus does not flip the graph. The minus and the plus right here does not flip the graph. What does this minus and this plus do to the graph? If it doesn't flip the graph, let's see if it will translate the graph. Okay? The word translate means slide. Slide to the left. Slide to the right. Crisscross. Crisscross. Everybody clap your hands. Okay, this is first period. We kind of still asleep. Alright, so translation is a slide. Here's the parent function. If we did not reflect across the X and we did not reflect across the Y, did we slide this parabola, class? Yes, we did. It slid. So when we have a vertex form with a minus or a plus in the parenthesis and a plus on the outside, we should automatically think, it's going to translate. So, look up here. Back at the essential question. Which one of these, 1, 2, 3, or 4, is responsible for translating a quadratic? When you look, 1 will translate a quadratic. Okay, now, that 1 is this plus 3. How did the plus 3 impact the parent function? It rose 3, right? Okay, so this plus out here on the end is responsible for translating up or down. Got it? If it's a plus, it's going to go up. If it's a minus, it's going to go down. It's going down. I'm yelling timber. Sorry. Couldn't resist. Okay. Now, we got the part where it went up or down. Which one is responsible for left and right? Where is the placement of the left? No, am I saying that right? Yeah. So we got the up and down part. Which one of these is responsible for left and right? The H, all right? So go back up to the top. Which format is the H moving the graph left and right? It's not 1. 4? All right, so this one translates left or right, and it's in the opposite direction. You down with OPP? Yeah, you know me. So I put translates left or right in the opposite direction. Okay. Everybody all right? So plus K is going to move it. Plus K is going to move it up or down. That'll be up. If it's a minus, it's going to go. Okay. Plus K on the inside is going to move it left or right. If it's positive, which way is it going? Right. And if it's negative, it's going to go. That's the opposite direction, right? Okay. Moving on. Where we going from here? We got to figure these two out. Now, rotate. Let's talk about this reflecting right here. We know this because if we take this parent function, y equals x squared, and we make it y equals negative x squared, what is going to happen to this U-shaped parabola? Fabulous. It's not going to be a U, it's going to become a what? An N. So this one will be a U, this one will be an N. Did we reflect, translate, or rotate? Rotate. I mean, technically we could have rotated 180, but we reflected across the x-axis. Okay? So, that was the minus sign in front of the x. Is that 2 or is that 3? The reflecting across the x to get it from a U to an N, is that 2 or is that 3? He thinks it's 3. He thinks that the oh, I see why you would say that. Do y'all agree with him or do you think it would be 2? Where's the negative sign? Is it with what's happening with x or is it with what's happening with the function? Function. The whole function is flipping. Okay? So is this the whole function that is being affected, or is it just the value of the input that's being affected? The whole function. You on and popping today. So which one of these, 2 or 3, will reflect across the x-axis? Alright, so 2 reflect across x-axis. Now, here's what happens with number 3. And I did not talk about rotating. Rotating is this one, and we haven't, I'm sorry, rotating is this one. I don't think I'm saying that right. I'm not going to talk about rotating right now. I need to figure out what is number 3. Here's what's happening with number 3 on the parent function. Let's say you take this guy, which is this parabola, and we put a 2 here in the front. So now every value of x is doubled, and then 2 is taken away from it. That is going to make the graph skinnier and wider. So that is a compression, or is it a shrink? You get what I'm saying? Remember, if the number was like 3 or higher, let's see, how did we do this? If the slope is 3, then that's 3 over 1. So that means you need to rise 3, 1, 2, 3, run 1, and it's a very steep line. If the slope is 1/3, then that means you rise 1 and you run 3, and the slope is not as steep. So when you manipulate the input, you are affecting the slant of the line, which affects whether it is vertically compressed or whether it is vertically shrunken. So number 3 is vertical compression. What was the other word? Stretch. And we did S-T-R-E-C-T-H. There you go. Okay. And this is how we describe the impact of adjusting a quadratic function. This should be second nature. Y equals mx plus b. The b tells you what the y-intercept is. It goes up or down. This one, vertex form, opposite direction. This one, plus or minus. You're going to flip it up or flip it down. And then this one is going to change the slope of the line. So if it's a whole number, it's going to increase very fast. If it's a fraction, it's going to be steep and not increase as fast. What questions do you have? Because now we're about to play. Huh? This one right here? No, I didn't label that. If I label it, what should we label it as? This one is, so these 3 things right here is what I was using to explain f of k of x. And that is the vertical shrink and compression. Vertical shrink or compress. I think I said that wrong. Vertical stretch or compression. Alright, we're going to play now. See if we can put this to use. Open your devices.